Um, taught yesterday, loops. So I'm not going to explain what's going on exactly, but just so you understand, there is a formula here. Okay? Let's see what it says. It's just a stupid Pi program, and we'll do it next week if you're still unsure about it. But the idea is that, in fact, this is how the very first accurate approximation of pi was determined. There was this guy, crazy mathematician, don't recall his name, who took a very large sheet of paper and dropped a lot of needles on that paper. And then he counted how many fell inside the circle and outside the circle. And using that count, he was approximating the value of pi. And that's how we are going to do it. In this question, you are going to do it. So the idea is that if you pick random points in the square, some of them will be inside the circle, some will be outside. And there are these questions you have to answer, like, what is the radius of the circle? Fine, we can probably tell that. What is the area of the circle? What is the length of the side of the square? So what's the area of the square? And then what's the area outside the circle but inside the square? So you have to answer those things. And then it says, we'll call the number of random points that fall outside the circle O, and the area outside the circle AO. And then we can use the equation that the number of points that we drop randomly is the ratio, Justin, the ratio of those numbers is equal to the ratio of the areas. That doesn't give you pi in any sense directly. But if you find a formula for the area of the circle, which we know contains pi, and a formula for the area of the square, which does not contain pi, if you find those formulas, you can say, okay, I know the ratio and I know the formulas, so I can solve it and I can get pi equals some other formula of the ratio. So you can't use the ratio directly, but if you're clever enough to know the area of the circle and the area of the square, you can actually derive pi. So it's not as directly as that. This is the program that is the solution, and it seems to work. Okay, it didn't quite there. It found that pi is equal to 2.8. But that's just dropping 10 pins or points. If you drop 100, you get to 3.2. If you drop 1,000, you get to 3.132. If you drop 10,000, you get closer and closer and closer. The more points you drop on the circle, on the paper, on the screen. So I promise you the formula is not broken. It's simply that you can't just print the ratio. That's not going to be the final answer. You have to do a little adjustment. Okay, Carlo's conjecture. How exciting. Really exciting stuff. This is not just a little cutesy thing. This is actually some kind of really fundamental mathematics that we work on a lot in our research. So Carlo's conjecture, yeah, fascinating stuff. What else is there? Oh, the interest. Oh, that's a little boring. It's not boring, I'm sorry. Some of you are BCom students, it's really exciting. You do it for the rest of your life, so I guess you really like it, all that. But, yeah, well. Right, and then, just one more thing, we also had a discussion about the project beforehand. I'll have another one, because yesterday I didn't cover all of it, but it was just enough to give you an idea of what the project is going to be about. And if you can already program, you can start on implementing that part of the project. Yes, Rivaldo? You were wondering if I could explain that? Oh, that at the bottom of the screen. So, this is not difficult, but man oh man, it's so boring that I'd really rather put this off until we have a little more flexibility in our schedule. But until now, we've been using this one command, print line. system.out.println, and it simply takes a string, or a number, or a double, what have you. Whatever I give it, it takes one thing, and it prints it out on the screen, and adds a new line. I don't have too much control. Whatever I give it, it prints in the format it wants. But I can exercise some control over how it's printed. So I'll have to use an alternative function. It's not too late, you can come in. We have a seat for you. So we have an alternative function, printf. It actually stands for print formatted. And then I don't give it one thing. I don't just give it a string or a number. I can give it many things to print. The first thing will always be a string, and it describes what will appear on the screen with placeholders for some of the stuff I want to print. And then after that, I put a lot of items, which is really what I want to print, and they'll be filled in these placeholders. Every placeholder starts with a percentage, like %t or %.2f. This first placeholder will be filled by month, and the D means integer. It's crazy, but it means integer. No sensible way of relating it. And then the F means a double or a floating point. So amount will be put in the second position, and month will be put in the first position. This .2 before the F means use two digits after the decimal point. I could also have said 5.2, which means it'll always put 5 digits before the decimal point and 2 digits after the decimal point. If I put nothing before the decimal point, I don't restrict it. If I put nothing after the decimal point, I don't restrict it either. So I can kind of control how many digits before and after the decimal point. I can even say how many digits should be printed here in this integer. So at the moment, the months, you see up to 9, it's 1, but then after 9, it switches to 2 digits in my month. So had I wanted to control this a little more finely, I would have, well, let's write a little program, since we will use a for loop, which will be ideal. You can all see that, yeah. Format, let's just call it format. A little bigger. I'll just steal from something else I did on Friday, which was, what did I do on Friday? Post ink. No, not Friday. Today's Friday. Don't be insane. Wednesday. Okay, so I'll make J into a double. Okay, that's fine. Then I switch to printf. I and J. And blah. Then I want to print I, and then I want to print J. And now, it's not print line anymore, so it's not going to start a new line. But almost always that's what we want. We want to print a whole line, and it'll start the next print and the next line. So you also have to add a new line, which you type \n. That's why I say this stuff is crazy, because all these shortcut codes you have to know or look up, and it's not very intuitive. Okay, so at the moment it's simply going to print I and J as they are in their natural state, and I could have done the same thing by writing this. J. And come on. Okay, Java C format.java. Format. Oh man. Doesn't want J. What does it want? Oh, J, F. My mistake. I was being too excitable. Well, that's it. Okay, fine. So it's not exactly the same, but it's kind of like free form. But now I can start to control it. So I can say, don't just put any number of digits, put exactly one digit after the decimal point. So I've control J, like that. And I can say, I don't just want I to be 2 digits. I want you to print 5 digits for I. Let's say 4. So now I has been printed with 4 digits. It doesn't have 4 digits, so Java just put spaces. But there's space for 4 digits. Had I wanted to actually put 4 digits and make them zeros, I could have said 0 for, recompile, run. So then it put zeros instead of just spaces. Or I could have said, I know this is crazy stuff, you're not going to absorb all of it, but at least it's being recorded. So I could have said -4, which means leave 4 spaces, use 4 spaces for I, but put it on the left-hand side of those 4 spaces. And just for comparison, let's do that. Clear the screen. Okay, so the -4 put the 12 on the left-hand side of its 4 spaces, and just the 4D put it on the right, and the 04D filled it with zeros. So you can do all this kind of stuff that I don't really want to tell you about, but I just have. And yes.
What if I had 5 digits, so more than 4?
What happens if I is bigger than 4? Well, it won't truncate I. Say again?
More than 4 digits.
Yeah, so you're absolutely correct. What if I was more than 4 and had more than 4 digits? Okay, right. So let's do that. Now, Java cannot truncate I. It can't throw away information because the place where this stuff is mostly used or most useful is often when you're working with currency, for example. And you don't want to say, oh, Mr. Smith, I see you only have 6,000 Rand in your account because I threw away the first 2 digits of your balance. So in that case, Java will just write the number, even if it violates the 4-digit specification. So in all cases, it'll just write the whole number. It won't change the values. So you have to know how many digits are in I, or at least what the maximum number could possibly be. Look, this isn't what we're supposed to talk about at all. I'm going to assume that you've done your reading. The reading for today was quite a hefty lot of pages, and it's all about gambling and simulation of gambling, and we'll get to that. But if we don't, I'm just going to assume you know all of it. These slides are about nesting, and we were supposed to do them on Wednesday, but they're pretty easy, and we have covered this material. So it actually starts with an if statement. And these 3 integers, A1, A2, A3, and I want to display whether they're just their sign. Are they positive or negative? One way of doing that is to say, well, if A1 is greater than 0, and A2 is greater than 0, and A3 is greater than 0, then print the plus, plus, plus. Else, if the first 2 are positive, but the third is negative, you can't see, or what? Yeah, you're right. There is a tiny mistake here there. But I'm not going to fix it now. Let's pretend it says 2. Okay, that's not the important part. The important part is that if the first 2 are both positive, but A3 is negative, then I'm going to print plus, plus, minus. Else, now I'm going to look at the next possibility, and so on. And this is going to be really deep because there are 8 possible possibilities. I'm discarding 0 for now. Let's say they're all known to be non-zero. It's going to be deep, and the code looks ugly, and it's difficult to read. So this is not what I want to write, and it's not what I want you to write. In particular because some of the demis had to have counseling last night. We had to rush them to a subject Just a little electric shock. I'm okay. We had to rush them to a psychiatric ward because of your indentation. They just couldn't handle it. And I went crazy. It's crazy. Right. So, even though this is horrible code and you'd never write it, and it's ugly and it's unreadable, at least it's still correctly indented. It could have been worse. This could have been all in one line. Or worse than that, randomly indented. Now, I know that I may have missed a beat, but I'm not telling you what the word indent means. And I think I've encountered people who don't really understand what I'm saying. So the idea is that I say indent, it really means push in. There's a dent, and it's in. Okay? This system.out@print line is inside these braces. So that's why it's pushed a little in. And some people use spaces, but I always use tabs because on most editors you can adjust how deep you want the tabs to be. So if one day I decide this is pretty difficult code, I want deep indentation, I just tell the editor, make the tabs 20 spaces. Then it's quite deep and I can maybe see what's going on. That's crazy, I won't do that. But sometimes I do it, put it down to 2, and then everything is indented by 2 spaces. Sometimes I adjust it. So I would just press one tab here to indent that. And the rest of the stuff, everything in the else, is also indented by 1 space or more. Some of it by more because they're inside nested braces. So indentation is really important. I have no hope of convincing you to indent properly. I just want to minimize the insanity. Okay? If I could just take out a few of the inmates at the asylum, I think it'll be calm enough for the rest to carry on. Ugly code, we're not going to write that. We may want to write this, much, much neater. So, all positive, print plus plus plus, else if the positive, negative, print plus plus minus. Else if, and so on. Indentation is still perfect. This, they're all inside one pair of braces only. That's why they indented 1 space only. And everybody's happy, except me. Because it's still 8 cases. And there's a clever way of doing it in this particular case. If I look at the variables one by one, I can actually do something that's a little clever. I can say, if A1 is positive, I'm going to print at least 1 plus. So let's handle that one case and look at A2. If A2 is positive, I'm going to print 2 pluses. So let's look at that one case. There are only 2 options. A3 is positive or negative. So I did plus plus plus, plus plus minus. And then this else is for this A2 being positive. I'm still in the A1 positive case, but I'm probably going to print plus, minus, and then something depending on A3. So really the code is a little neater because I only have one condition to look at in every if. But of course, I mean, there is an even simpler solution, which we want to get to, and that's to just look at all 3 of them separately. Look at A1 and print the plus or minus. Not print line, but print. Then look at A2 and print the plus or minus, and look at A3 and print the plus or minus, and then I do the print line separately. Because tomorrow, I could put the print line in there, because that's the last plus or minus, but tomorrow I want to add A4, and then I might forget. So yeah, yes, Craig.
You probably simplify that a lot faster by saying when A2 is greater than 0, then the system print plus plus, and if it's smaller than 0, then system print minus minus. Because both A2 and A3 are the same thing.
Very, very true. But as I've remarked to Jung, I know it's a little mistake on the slide. And let's ignore that and pretend it's different. Oh, shots. What's going on here? Oh, do I have to plug it in?
Yes.
It's the wire. Okay, don't panic, people. It's just that there's a little break somewhere in this wire, and when I jiggle it, makes a little noise. Don't be upset. Fine. Right. Craig, you happy with that brilliant explanation? I come across this code one day. I like it. It's simple. It takes one thing at a time. It's neat. It's correctly invented, which makes me really happy. But I do wonder if I can't make it shorter, because there's a little bit of a pattern. So, I think about writing this. Yes, I know, Craig. A2 and A3 are the same. But let's pretend that also on this line, there's a little mistakey. Let's just pretend that that is a 2. Good? Right. Now, who's in favor of this? Who thinks this is clearer and easier to read? And we should be writing this because we are communicating with humans. Yes. You are the deviants. Who believe we should stick to our principles and be consistent, because in the long run, that will help society and make it a safer world for everyone. We need the code. You are the fanatics. So we have a class full of fanatics, deviants, and apathetic people who just don't care. Just want to watch the world burn. Either way. If I were to write this code, I would write this. It's not going to kill everybody, and it's clearer. And at the end of the day, we want to communicate. So I am prepared to break the rules, and it's always important to know when you should be breaking the rules. I know I should be indenting. I know my usual habit is to write everything inside the braces of this if on a new line, but I think in this case it's acceptable and better to write it like this. Ooh. Pay a certain tax rate depending on income level. We have talked about this before. If my income is 0 to 47k, this is annual. 47k does not sound like much, but in the US, it's good, isn't it, Marco? I mean, it's not good, but it's livable.
Yeah.
Well, it's not 0, but 47k. Right.
Yeah.
Zero is more than you make.
Yeah.
Yes, it is. True. Okay, right. Yep. 47k is okay salary annual for in the US. I don't know what the tax rates in the US are, but 22% is quite realistic. South African tax rate. It's on the low end. That's what you'll be paying. And let's say that's the rate. And now we're given the income, we must decide the rate. So we could write this. Oh man. It starts by saying the rate is 35%. Why does it do that? Any ideas?
So that you can ask to bring it in for the last statement.
Why not?
Makes things easier, you don't have to do it. And also because everything about
Does it make it easier, or is it more logical to say, this is your salary, this is your rate, this is your salary, this is your rate, this is your salary, this is your rate? Instead of explaining to people, okay, right, you start off with a rate of 35%, and now we're going to see if it should be lower. I think it's more logical to put the else. But, just in case we made a mistake, this is actually safer, because now we are setting some rate. And in case we leave out some case, at least we are assured that rate has a value. It's not undefined. So I don't think your explanation is quite exactly correct. I mean, you are saving an else at the end, but I think this is for safety rather than just saving space. So it says if the income is less than blah, 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 the rate is that, else if income is less than that, the rate is that, else. Once again, not following the rules exactly, but it is kind of clear and neat, and I would be happy to read this in one of your programs. Everything is nicely aligned, but in general, this is not how we want to write code, because people who do this kind of thing, align it, they take it a little too far, and I want to align everything in the whole program. So all the variables must be aligned in the 5th column throughout the program. Screw the indentation. Even if I'm deep, I'm going to move it back so that everything is in column 5. That's not the way to go. You need medication. So, often on the slides, I do actually write like this because just to save space. Don't have unlimited space on the slide. So everybody's happy with this. If my income is less than that, that's my rate. Otherwise, if my income is less than that, then I can have that rate. Else, if my income is less than that, I can have 28%. Else, if my income is less than 210, I can have 33%. Else, I'll be stuck with the 35% that I guessed originally. There is no else, so the original will apply. How do you feel about the following slide? I've eliminated all those else's. I've made the code much clearer. Not happy, Rivaldo? What's wrong?
So if it is less than 47,000 something, then you obviously be less than everything else below that.
Are you saying that if that is true, then that will also be true?
And then
That will also be true.
and
That will also be true. And we'll be stuck with a rate of 33%. So even though I've made my code a little clearer, I've actually broken it. I must be able to think like the computer will think. Neat code is not always the solution. Sometimes not so neat code can actually help you. Okie dokie. Favorite exercise that even clever students sometimes get wrong. All I ask you is to draw that figure. And maybe using a lot of for loops. This is a good exercise because it teaches us a little bit of problem solving. It teaches us a little bit of problem solving. What am I going to do? I need to print this figure. Many students approach this problem by panicking wildly, crying, and quitting computer science. And that is a valid approach. Let's not say that's wrong. Okay? Maybe it's the right decision. But I don't know, somehow people find it really difficult to. You want to quit? What?
Yeah.
Oh no. Yes.
It's been fun.
Say again?
It's been fun.
It's been fun, but this is too much. You have to draw the line somewhere. Yes.
No, can I make this?
Yes, please do.
Okay. Could you use a while loop? And
I could.
And then for every n which is greater than 1, you print this asterisk. And for every n that is equal to even number, you print line. And then you leave what's on the bottom.
Except, that's almost right, except when n is equal to pi. And then we are going to print an exclamation mark. No, sorry, you lost us. It's too complicated. We already lost. I'm lost. I've been teaching this course for 20 years. I don't know. Wow. No, I want a much simpler solution. Much simpler than that. And the solution I want is don't panic. Step 1, don't panic. Step 2, let's just use a for loop. We know we're going to print n equals 6 lines, n lines. So let's write a for loop that will execute n times. And what do I do inside each iteration of the for loop? Print 1 line. So I'm going to lie to myself as I do every night and not do this work. I'm going to say, get the n. Is this the right marker? Craig? Happy with this? Good, excellent. Pick up n and have a for loop that starts at 0 and goes up to n but doesn't reach n. So it's going to execute n times, 0, 1, 2, 3, 4 to n minus 1. And inside, I don't do anything. I just draw line I. I do this all the time when I program. Instead of writing the code, the actual code, I just put a little comment to say what I'm supposed to do. Then I leave it for a while. I'll nap for half an hour, have a cup of tea, There may be a biscuit, and I get back to it, and I can approach the problem of drawing line I. I don't have to worry about anything else. All I need to think about is how do I draw the ith line? So let's analyze a line. Let's just take this line. Well, it starts with a couple of spaces, and then it has a lot of stars. So I've got to draw spaces and draw stars. And I have to figure out how many spaces and how many stars on line I. So let's make a little table. Line 0, how many spaces? 0. Line 1, how many spaces? 2. Line 2, how many spaces? 4. Line, what? Not 9, 4. Line 3, I've got 6 spaces. Line 4, I've got 8 spaces. So it sounds like in line I have 2 times I spaces. Okay? Remember that, 2 I spaces. Okay, now, how many stars? A little trickier, but let's take the very first line. How many stars are in this line? If you say so, I don't even care. Okay. So 12 stars, and all the lines are the same width. This line also contains 12 characters. Some spaces, some stars, but 12 characters. And the next line contains 12 characters, and 12 characters, and 12 characters. So I know that if I print in this line 2i spaces, I still need to print 12 minus 2i stars. I don't need to find a formula for the stars. I know there needs to be 12 characters, 2i are spaces, and 12 minus 2i are the stars. So that's my little formula for the number of stars. Okay. So let's see what okay. Draw spaces on line I, draw the stars on line I, then print line. Yeah, I should have thought of that. Nap, tea and biscuit. Next. Okay. So I've got a new variable SP that starts at 0 and goes up to 2i, and every time I just print a space. So that's 2i spaces. Nap, tea and biscuit, get back. Ooh, no. I made a little change. This is just cosmetic, and it's not important. This would earn you full marks. But I see that there's 2i spaces, and every time I print one space. But it would actually make a lot of sense to print 2 spaces at a time and just print I of them. It's just a small little optimization to confuse people in class. Who is making that noise? It's not me, is it? It could be the static. Okay, right. Nap, biscuit, here are the stars. So it's supposed to be n minus 2i, but using the trick of the previous line, I say just n minus I times print 2 spaces at a time. Kind of. Is everybody happy with this? Will you be able to draw funny shapes? Okay. So everybody's ready to print, to draw this kind of stuff. Still happy? Okay, excellent. What about this? Little pyramids and triangles. Can I think of anything else? Oh yeah. Okay. What about like a little grid? I think this may be taking it too far. but everybody's happy with that? I'm asking because, if I remember correctly, these are all shapes I've asked in tests and exams. So you get to the test and there's a question that says, write code to draw this kind of stuff. So it's a stupid little exercise, but it tells me that you can avoid panic, and you know how to use a for loop, and you know how to use a print statement, which is quite important. Okay. Let's just start a little bit with what we were supposed to do today, and then we stop. I stop. What is the biggest gambling destination in the world? No. 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 Las Vegas is not the gambling capital of the world. Say again? No. You can try it. Monte Carlo is not. No. So the gambling capital of the world is Macau. Most money is spent on gambling, most income derived from gambling, biggest casinos and all that. I don't know where this is. This is probably Las Vegas. But we are going to talk about gambling a little bit, because in computer science we often do this kind of thing. It's called a Monte Carlo simulation. There are also other kinds of simulations, like Las Vegas simulations, but let's talk about Monte Carlo simulations. So I've got this game I'm playing. I'm going to flip a coin. There's a gambler. He starts with a certain amount of money, his stake, and he bets $1 on every coin flip that I'm doing. And if he's right, he calls it, and if he's right, he gets his dollar back and another dollar. But if he's wrong, he loses his dollar. So after every coin flip, he either gets an additional dollar or loses a dollar. His fortune goes up and down. He starts with his stake, let's say $10, and it goes up and down based on the coin flips, up and down. And if he gets to some goal, like $20, if he's doubled his money, he wins. And if he gets down to $0, he loses. And I want to know, what are his chances of winning, of getting to his goal? And how many coin flips on average does that take? Will he have to be there all night, or does he always win or lose within, let's say, 50 coin flips? How do I determine this? Do I use advanced mathematics? What? Or do I use advanced probabilities or stats? I can try, but it's quite a difficult process. Probability and stats are good with kind of more static problems. This is a little trickier. They can do it, but definitely not with anything you're going to learn soon. So, an almost better way of doing this is to use a simulation. I'm going to write a little program that simulates what's going on here. I'm going to run it 1,000 times, and then I can calculate the average. And it doesn't mean that I'll get the precise answer, but the longer I run it, the better my approximation of the answer. It's better to know that on average it takes 25 coin flips to go from $10 to either 20 or 0. On average it takes 25 coin flips than to not know anything at all. Even though 25 may not be the right answer, it may be 24.888, maybe 25.001, but I'm getting close, and I can get closer if I want by just repeating the number of simulations I run. So I'm going to write a little program for this. I'm going to repeat and compute statistics okay, so here we go. Do we go or do we stop? This is fascinating. This is the most exciting stuff program we've written in class since the course began. Got a class called Gambler, got a main. I pick up 3 values from the command line. The stake that Gambler starts with, his goal or her goal, and the number of times I want to repeat this whole exercise. And I'm going to keep track of the number of times the gambler has won. So wins starts off as 0, and right at the end I'm going to just print he won 0 times in trials, however many times I've run the simulation, runs. And now I have to fill in the code in the middle. Now there's not enough time to do it, so I must either show you a little bit or just put the slides on the web. I think so too, because it's so exciting. I still have to repeat all of this in Afrikaans. So let's quick summary. Everybody relax. Don't put your pencils away. Because it's going to make a noise. Don't cough. Everybody like sick people. Nou. Waar het ons gepraat? Vinnig, daar's nie 'n probleem met die Pi tutoriaal opdrag nie. Dit is net dat jy self die formule moet ontwikkel. Dit is nie net so eenvoudig as om die 2 areas te deel nie. Dit gaan nie vir jou Pi gee nie. So, ons het eintlik gepraat oor nesting van ifs en van for loops en die feit dat ons dikwels die reëls van indentasie kan breek as dit netjieser gaan lyk. Maar die primêre doelwit is om netjiese kode te skryf. Want ons skryf nie die kode vir 'n rekenaar nie, ons skryf dit vir ander mense. En ons wil hê hulle moet dit kan lees en ons moet dit self kan lees. So dit is baie belangrik om netjiese kode te skryf. So ons kyk na daai hele if storie oor die positief en die negatief. Ons het gekyk 'n bietjie na daai if stelling wat die belastingkoerse bereken en dat mens versigtig moet wees daarmee. Dit maak nie altyd sin om net al die else uit te haal en dit mooi korter te maak nie. Soms beteken die else iets belangrik. En daai belastingprobleem kon ons nie van die else stellings ontslaa raak nie. En toe het ons gekyk na daardie figuurtjie wat ek gedruk het met die sterre en die spasies en die feit dat dis nie moeilik om dit te doen nie. Jy moet net nie paniek bevange raak nie. Ons druk dit gewoonlik lyn vir lyn en jy moet net mooi besluit wat moet op elke lyn gedruk word. Dit ons begin met hierdie Monte Carlo simulasies, maar daar is nie genoeg tyd om dit klaar te maak nie. Maandag moet ons met arrays begin. Arrays is 'n Engelse woord. Engelse mense gaan nie weet wat dit beteken nie, maar ek sal nog steeds vra. Moenie julle sê as julle weet nie. En die Afrikaanse woord vir array is 'n loop. 'n lus. Array. Nee, 'n lus is 'n loop. Net een oomblik, dat is het weer verkeerd. Engels loop, Afrikaans lus. Dus die lus in de touwkie. Als je knop maakt in de touwkie, maak een lus. Soos een lasso in Engels. De Afrikaanse woord voor array is skikken. Rangskikken. Het is een skikking van elementen. Ons gebruik dit al voor die laatste 50 jaar. So, bestaande woord. Dit is niet wat eigenlijk opgemaakt. Right, so I see all of you on Monday at 11 and everybody will be happy. Now I have to stop this recording.